Welcome, team. Today, we are focusing on a critical aspect of maintaining machine learning models in production, detecting and analyzing data drift. Let's ensure our models remain accurate long after they are deployed. Let's start by defining data drift. What is it? It's the phenomenon where the statistical properties of your production data change over time, drifting away from the data your model was originally trained on. The basic premise is simple. The real world changes, but your model does not. Why do we care? Because if we ignore this, our models will experience drift or degradation over time, directly harming our business outcomes. How do we track this? We must actively compare our baseline training data against live inference data. For a deep dive, when you are calculating the total cost of ownership for an AI solution, you must factor in the costs for data cleansing, labeling, and continuous monitoring of data drift. It is not a one-time deployment, it is a continuous life cycle. Look at this flowchart. On the top left, we have our training data snapshot, representing a fixed point in the past, feeding into our deployed model. On the bottom left, we have evolving real-world data constantly hitting that same model. This mismatch creates the central conflict, data drift. As the arrows show, this drift inevitably leads to decreased accuracy over time. Our goal is to catch this before it impacts our users. To identify drift, we must perform a systematic comparison. What are we comparing? We are comparing our historical training dataset, which we call our baseline, against the live production requests, which we call inference data. The basics dictate that we must actively capture the telemetry of what our model is experiencing in the real world. Why is this necessary? Because we need mathematical proof to determine if the live data still matches the patterns the model understands. How is this done? Azure ML provides built-in capabilities to monitor applications for operational issues and to actively compare model inputs between training and inference. Taking a deep dive, this means your deployment architecture must include data collection directly at the endpoint. If you aren't logging the incoming live requests, you have no inference data to compare against, making drift detection impossible. This sequence diagram illustrates the data flow for drift detection. First, the training data, acting as our baseline, sets the statistical expectations in the drift monitor. Meanwhile, the production endpoint is busy logging all live requests, effectively creating our inference data target dataset. This target data is continuously sent to the drift monitor. The monitor then executes the final step, continuously comparing the live distributions against the historical baseline to spot discrepancies. To effectively manage drift, we must understand its root causes. What causes data to drift? It is the underlying real-world changes that shift data distributions. The basic reality is that data drift is usually not a bug in your machine learning code. Rather, it's an accurate reflection of a changing environment. Why must we find the root cause? Because the fix depends on it. If consumer behavior changes naturally, you must retrain your model. If a thermometer sensor breaks and sends bad data, you don't retrain, you fix the sensor. How do we do this? We categorize drift into natural shifts, like seasonal buying trends, versus systemic data pipeline errors. For a deep dive, we monitor tools and practices to assess and report on system health. We look for covariate shift, where the input features change, ensuring our real-time alerts catch these anomalies before they break downstream business logic. Here we break down the root causes of drift. From the top node, we split into two main branches, natural shifts and systemic errors. Under natural shifts, we see things like changing consumer trends or seasonality. These require model retraining. Under systemic errors, we see broken sensors or schema changes. These require data engineering fixes. Understanding which branch of this tree your drift falls under dictates your entire incident response. We cannot rely on humans to check data files every day. We must establish continuous monitoring. What does this mean? It means setting up automated systems that evaluate data health entirely without manual intervention. The basics involve scheduling jobs in Azure ML that wake up daily or weekly, compute the statistical drift magnitude between your baseline and your live target data, and record the results. Why is automation essential? Because manual checks are infrequent and guarantee that drift will go unnoticed for too long. How is this achieved? We implement infrastructure that can continuously monitor applications for operational issues and machine learning specific metrics. For a deep dive, an enterprise MLOps strategy requires fine-tuning. You must configure precise mathematical thresholds using statistical distance algorithms. If the threshold is too low, you get alert fatigue. If it's too high, the model silently degrades. Precision is key. This sequence diagram shows the heartbeat of a continuous monitoring setup. Inside the loop, which runs every 24 hours, the scheduled drift job automatically fetches the baseline and the most recent inference data from storage. It passes this to the statistical engine to compute the exact distance metrics. The engine returns the drift magnitude, which the job then records into the MLOps dashboard. This daily heartbeat ensures we are never caught off guard by degrading data. Monitoring data is useless if no one knows it's failing. This brings us to automated alerting. What is it? It is the proactive notification sent to your engineering teams the moment data drift exceeds your predefined acceptable bounds. The basics involve taking that continuous monitoring job we just discussed and attaching an alert rule if the drift score crosses 0.4, send an email, or trigger a PagerDuty ticket. Why do we need this? Because a dashboard is passive. It only works if a human remembers to check it. Alerts provide immediate, active awareness. How do we build it? Azure ML allows you to notify and alert on crucial events in the machine learning lifecycle, explicitly including data drift detection. Taking a deep dive, an advanced alerting architecture includes intelligent routing. It shouldn't just spam a channel. It should route schema errors to data engineers and statistical drift alerts to the data scientists responsible for retraining. Observe the alerting logic in this flowchart. The continuous monitor constantly evaluates the data. It hits the decision gate, drift threshold exceeded. If no, it simply logs the data and goes back to sleep. But if yes, it immediately takes the bottom path, activating the trigger alert system. This node acts as an automated dispatcher, simultaneously sending an email to the data science team and opening a formal ticket in Azure DevOps. The team is instantly mobilized to investigate the drift. An alert has fired. Now what? We enter the phase of analyzing drift telemetry. What is this? It is the diagnostic investigation to understand exactly what broke. The basics involve opening the Azure ML Studio and looking at the visual drift dashboard to see which specific data columns are drifting. Why is this analysis so vital? Because not all drift is fatal to your model. You must determine the actual impact. How do we investigate? We use the platform to explore model-specific metrics, comparing the specific input shapes between training and inference. For our deep dive, the secret weapon here is feature importance. If your dashboard shows that a feature with a 90% importance weighting has drifted drastically, you have a critical production emergency. However, if a feature with a 1% importance weight is drifting, your model's accuracy is likely fine, and you can safely adjust the monitor's threshold rather than panicking. This flowchart maps the triage process for a data scientist. An alert is received, prompting the engineer to open the Azure ML dashboard. They ask which feature drifted and isolate feature X. Then comes the critical diagnostic question: does feature X have high feature importance? If yes, it routes to critical, model at risk, immediate action is needed. If no, it routes to low priority, preventing the team from wasting hours on a false alarm. Once we confirm harmful drift, we must act. This is remediation, closing the MLOps loop. What is remediation? It is the concrete action taken to restore your model's accuracy. The basics almost always involve triggering a new training pipeline, but this time, you include the recently collected, drifted inference data so the model learns the new reality. Why? To force the model to adapt and restore its business value. How is it executed? We don't train locally. We trigger our automated CI/CD pipelines to retrain, evaluate, and deploy. Our deep dive focuses on governance. When you retrain, you must capture the governance data for the end-to-end machine learning lifecycle. Your logged lineage information should explicitly state that this new model version was published because data drift was detected on a specific date. This creates perfect auditability and transparency for your AI operations. Let's walk through the remediation lifecycle. We start on the left with confirmed data drift. The team curates a new dataset incorporating the recent shifts. This feeds into the trigger training pipeline node. Once trained, we hit a critical safeguard: evaluate new model versus old model. We ask, does the retrained model actually have better accuracy? If yes, we successfully register and deploy the new version. If no, simply adding new data didn't work, and the team must route down to investigate architecture to rethink the algorithm entirely. Let's apply everything to a real-world scenario. We discussed Prosware, a healthcare startup with a deployed diabetes classification model. Over the course of a year, the application began seeing a subtle demographic shift in the hospitals using the app specifically. The average patient age and BMI were different from the original training data. The why is critical here. In healthcare. You cannot allow models to silently degrade. Misdiagnoses are unacceptable. The how. Prosware had configured an Azure ML data drift monitor. It automatically compared the inputs between the historical training data and the live inference endpoint, detecting a massive statistical shift in the BMI feature. For the deep dive, the monitor instantly notified the MLOps team. They opened the dashboard, saw that BMI was a crucial predictive feature, and immediately triggered their automated GitHub Actions pipeline. The model was retrained on the new demographic reality and safely deployed, completely mitigating the risk. Our final diagram shows the Prosware incident response in action. Patient data flows from the live endpoint into the drift monitor. The monitor catches the BMI distribution shift and fires an alert to the MLOps team. The team analyzes the feature importance, confirms it is high impact, and triggers the GitHub Actions retrain pipeline. The updated, accurate model is seamlessly deployed back into the healthcare ecosystem, proving the massive value of automated drift detection.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment. Or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.